Okay, so what are the different rules that are used to in the reduction of block diagrams? Okay, so a block diagram reduction help us get the system overall transfer function, give the relation between input and the final output directly without any kind of issues. So what are the relations that we have? These are the different rules that you can use. So this is the original block diagram, and this is the equivalent reduced block diagram. So what you can see is that if we have an input X and output Y, between them we have a block G1 and then G2. Okay, so by logic, this is the first output here, X entering a G1, right? So the output of this block will be X multiplied by G1, right? Now XG1 is entering G2. So the output of this block will be X G1 G2, right? So it means that Y is equal to X multiplied by G1 G2. So Y equal to X multiplied by G1 G2, which means that we can say that X as an input, Y as an output, between them the gain G1 G2, like this. So you convert it from 2 blocks to 1 block. Now let's look at this one here. So we have X G1 to this is called summing node, okay, node, like this. So it is used to add two values, add or subtract. It can be summing node or subtracting. You can see a plus, and the plus will be summing node, and plus minus will be subtracting. Okay, so what happens here? You can see X entering the first block, right? So the output of it will be X multiplied by the gain here, which is G1, and X entering the second block, X G2. Now their summation or their difference will give us Y. So we can say that like this, we have X entering and Y leaving. Between them G1 plus G2 or G1 minus G2. So it will be G1 plus or minus G2. Okay, as you can see here. Okay, another one. Let's say we would like to, we have here U, which is our input, and Y is our output. Let's say I would like to move this point here. You can see from this point we take the value here. Value here is U, right? So I take this U. Now let's say I would like to move this point here. Sometimes we do this in block diagram reduction. So I would like to take the output, instead of from here, I would like to take it from here, like this. So you can see this point will have U multiplied by this gain, G, right? So I would like to take the same U, same I did here. I would like to take from this point U. So all I have to do is that this point has UG. So I'm going to divide it by G. So it will be here like this, 1 over G. So it will give us U, right? So 1 over G multiplied by UG gives us U. That is what we did here. In order to move this point from here to here, we have to divide by this additional gain. Now, what if I did the inverse? Let's say I would like to take this point to here. Take it from here. Now, by logic, you can see that this point is UG, right? So the output which I am taking is UG. So if I take it from here, I will have here only U. So I need a gain of G in order to take the same output UG, right? That's why we will have a gain here. Now, let's say we have two difference points and we have Y. So here we will have U1 minus U2 entering to a gain G. Okay, so our output Y will be U1 minus U2 multiplied by the gain G. Okay, as you can see here. Now what if I would like to move this summing node here from this point to here? Okay, move it after close to y. So how can I do this? All I have to do, if I move this point here, then this gain will be distributed across these so that we can get the same solution. So you can see that this is GU1 minus GU2, right? So what we did is that if I convert both this point here, then it will be U multiplied by G and U multiplied by G, like this. Okay, you will see that UG minus UG, right? UG minus U and G, like this. So it is exactly similar to each other. All I have to do is that I move this point after the gain. Similarly, if I have it, this one U and G, and I would like to take this summing node here, like this. So let's look at the output here. In the output here, we will have Y equal to U1G, which is a positive, U1G minus U2. Okay, now if I would like to move this point here, then you will find that we will have U1 like this, plus or minus G Y. Okay, and if I keep it U2 as it is like this, then you will find that the output here Y is equal to U1 minus U2 multiplied by this gain G. So it will be U1G minus U2G. Okay, now as you can see, I would like it to be U1G, so this one will be as it is. However, you will see that I would like only U2, but we have here U2 multiplied by G. So in order to remove this, I need to multiply U2 by 1 over G, right? How can I do this? By adding here a block here of 1 over G to eliminate this G and return it to the same solution, as you can see here.